There we go. Okay, so now we're moving on to section 1.3, and we're going to cover something that I'm willing to bet you have all seen before at some point in algebra. Out of curiosity, what is the square root of 9? 3. What is the square root of 16?
4.
Okay, good. And I can keep on picking these. What is the square root of 2? No, 1 times 1 is not 1. It's not 2.
So that's 1 point something.
You are all aware that it is a number that does exist. The fact that you do not know it simply means it's 1.4142, da 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 da. It's a decimal that goes off forever. It's an irrational number, but it does exist, right? Yes. Good. Okay. Well, then what about this one?
You get an imaginary number.
The square root of negative 9. Can you take the square root of a negative?
No.
No?
Well, you get an imaginary number.
No, yes. It kind of depends on what you've actually done as far as math is concerned. A lot of times in high school, when you see the square root of a negative, you stop because it's a non-real solution. But now we get to actually solve them all out, which I'm sure you've seen before. Does anybody actually know what it is? There's a trick to it. The square root of negative 9 is equal to the square root of 9 times the square root of negative 1. What's the square root of negative 1? I. Okay, we all heard of I before. Yes? I is the number that has the property that I squared equals negative 1, which essentially allows me to solve all these out. So I get the square root of 9 times the square root of negative 1, which is I. And then the square root of 9 is 3, so it's 3i. So we've all seen that before. Okay, good. Essentially, the only reason we really care about that is we will be solving quadratics and cubics and quartics and quintics and all that other fun stuff. And a lot of times in high school, you kind of stop once you get to the non-real stuff and say there's no real solutions, so I'm done. We don't get to do that here. We get to keep on going until we get all the solutions, which means they might be complex. Are you all aware that this is called a complex number? You are. You know what a complex number is?
It's any number that isn't like a real number.
Actually, all real numbers are complex. Real numbers are a subset of the complex numbers. They're more complex numbers, so they give us more. Okay, essentially the idea is this. Complex numbers are numbers of the form a plus or minus bi, where a and b are real numbers. Essentially, the idea is if you had something like 2 plus 4i, that's a complex number. 2 and 4 are real numbers. I is just the imaginary part coming along because of the I, which is imaginary. You could have 6 minus 7i. Doesn't have to be plus, can be minus just as well. As far as the real numbers go, what if b was 0? Then you would get 3 plus 0i. 0 times anything is? 0. So this is 3, which is a real number. So all the real numbers are complex numbers. You just don't actually call them that when you learn about real numbers because you're not talking about the complex ones. But essentially everything, integers, fractions, decimals, they're all just complex numbers. Got it? You can also flip it and you could get 0 plus 3i, which is just 3i, because you don't like the 0. That actually, if you care about the math terminology, is called purely imaginary, because it's only the imaginary part. The real part is over here, the imaginary part is over here. Get the idea? Pretty easy? Okay, good. Well then, you have all seen these before, but kind of the way this works in math, anytime you define something new, a new set of numbers, you have to redefine all your operations on those numbers to make sure your operations actually work the same. Sometimes they do, sometimes they don't, sometimes you change them, sometimes they don't work at all. So we have to run through all the operations again, addition, subtraction, multiplication, and division, to make sure they actually make sense. Okay? Good. So, let's see. Oh, and the one thing I will say at the outset, as far as complex numbers, which is really, 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 really important, you have all worked with fractions, right? Yes. And when you work with fractions in like 3rd grade, the first thing your teacher tells you once you know what a fraction is your answer must be in simplest form. And then you learn about mixed numbers, and your teacher tells you that if you add 2 mixed numbers together, your answer has to be a mixed number, right? Can't just go into your calculator and get a decimal. When you add 2 decimals together, you have to get a decimal. You're not allowed to write it as a fraction, right? Generally speaking, people don't write the fractions, they use their calculator and get the decimal, and teachers make you write it as a fraction. Same principle here. We're talking about complex numbers, which means every answer when you're working with complex numbers has to be a complex number in standard form. A plus or minus bi. Which means if you solve the problem correctly, but don't put your answer in standard form, it's wrong. Okay? And we'll kind of make sure to be clear on that as we write this out. But let's see. First off, I guess we have addition. So suppose we have 2 plus 3i plus 3 plus 4i. Add those together. What would you do? Yeah. Yeah, essentially, while this is new, it's actually really old stuff you already know. If this was, I need a different color, 2 plus 3x plus 3 plus 4x, you wouldn't even think about it. Combine like terms. 2 plus 3 is 5, 3x plus 4x is 7x, and you're done. If it works with an x, it works with an I. Same principle. 2 plus 3 is 5, 3i plus 4i is 7i, and you're done. Easy, right? So that was about 30 seconds. Do we need to spend longer on addition? No, it's just combining like terms. But all of you then are aware that addition and subtraction are really the exact same thing, right? Which means subtraction should follow the same way. So suppose you have 3 plus 4i minus 2 minus 3i. You want to solve it all out? Combine like terms. But what's the trick here? What do you have to be aware of?
You're subtracting
Distributing your negative inside the parentheses. One thing I'll point out here, generally speaking, as the instructor, when I'm writing exams, I will deliberately put one problem somewhere on an exam which has a negative in front of parentheses. Because it's an algebra class, and I want to see if you know your algebra, which means I want to see if you remember to distribute this negative sign into the parentheses. I'll create an incredibly complex problem, and the only reason to write the problem is to see if that negative goes inside those parentheses, and that's it. To see if you remember that trick. So right here, that's a little guideline for future exams. 3 minus 2 is 1. 4i minus minus 3i. 2 negatives cancel, and that becomes plus. 4i plus 3i is 7i. And we're done. Easy? It's like 30 seconds more, I know. So one more to convince me. 2 minus I minus 3 plus 4i. So same thing. 2 minus 3 is minus 1. Minus I minus 4i, that stays negative. So minus 1 minus 4 is minus 5i. One thing I'll point out, both to you guys on online and to you in the class here, I'm taking as a given that you know a whole lot of basic math, for lack of a better way of saying it. You can work with fractions, you can combine like terms, you can distribute and all of that. If there's ever a question, which based off of past history there probably will be, just ask in class, come and see me. You guys can email me or whatever. But yeah, I'm kind of taking it on faith that all this basic algebra you know. Okay? So we go with subtraction then? Yes, which means we're halfway home and it's only been like 2 minutes. According to the video, yes. So what comes next? After addition and subtraction is? Multiplication. So we multiply. And suppose we have 2 plus 3i times 3 minus 2i. If you wanna multiply them, what do? You all know this because you've all been doing it for years, right? What do? Person nodding their head over there.
We need to, I don't know, we used to use the box method to multiply them, but
Oh yeah, they teach that nowadays. I have no idea what it is. They didn't teach when I was in school. Does everybody know what FOIL is?
First outer inner.
First, outer, inner, last, yeah, which is the same as the box method. I will point out, when I was actually in school, I was told to FOIL, and I assumed that foiling was another word for multiplication, because you did it when you multiplied. It wasn't until much later, actually, when I was teaching, and somebody pointed out to me, FOIL stood for first, outer, inner, last. I didn't really grasp that concept when they taught it to me in high school. But sure, first, outer, inner, last. So first, 2 times 3 is 6. 2 times negative 2i is negative 4i. 3i times 3 is 9i. 3i times negative 2i, positive times negative is negative 6i squared.
I squared.
And then, all of you know the next step, combine like terms. So we get 6 minus 4i plus 9i. 9i minus 4i is 5i. Minus 6i squared. And the only problem is what? That's a complex number, which means it has to be in standard form. Is that in standard form? No, because I have an I squared floating around. But what do? What's the property of I squared?
I squared is negative 1.
-1, which means substitute in. Replace I squared with -1. And you get 6 plus 5i minus 6 times -1. Negative 6 times -1 is positive 6. So you get 6 plus 5i plus 6. Combine. 6 plus 6 is 12. So you get 12 plus 5i. There you go. Complex number, standard form. Make sense? Okay, good. Then, while I reset that video there for the people online, you guys solve this. 2 minus I times 3 plus 4i. Yeah, that's different.